At the external edge of our planetary group lies Pluto, a divine secret that has intrigued cosmologists and space lovers the same. When considered the 10th planet in our planetary group, Pluto's renaming as a bantam planet didn't decrease its charm. However, the astronomical community has received brand new information. There are rumblings that Neptune and Pluto might get into a fight. What implications does this have for our solar system's future? Could it be said that we are going to observe an extraordinary world accident? The tale of Pluto is one of secret and hypothesis. Since its revelation in 1930, Pluto has fascinated researchers with its surprising circle, which contrasts altogether from the principal planets in our planetary group. Pluto's journey around the Sun takes 248 years, compared to the circular orbits of its fellow planets. Adding to the secret is the slant of Pluto's circle, which has a point of 17.1 degrees comparative with the plane of the circle. What truly separates Pluto is combination with Neptune's circle. A combination happens about at regular intervals. The back and forth among Pluto and Neptune has long intrigued space experts. There hasn't been a crash, even though they're close together. Be that as it may, why? Their orbits are governed by a complex dance of gravitational forces, which provide the answer. Pluto crosses Neptune's path safely, more than 90 degrees from Pluto's position due to the nature of the orbital space. The two celestial bodies are prevented from getting too close by this gravitational shield. In any case, might this fragile equilibrium at some point be upset? We must examine the three-body problem, a problem that has baffled scientists for centuries, in order to comprehend the dynamics involved. The three-body issue includes foreseeing the movement of three heavenly bodies, like Pluto, Neptune, and the Sun, in view of their associations. This issue is made more difficult in the case of Pluto and Neptune because other large planets in the solar system, like Jupiter and Saturn, have a significant impact. Cosmologists have recognized a few key factors that add to the security of Pluto's circle. As referenced before, the stretching of the circle helps keep Pluto and Neptune at a protected separation from one another. Also, Pluto's circle will be essentially over Neptune's orbital plane when the two bodies are nearest to one another. This additional layer of assurance decreases the gamble of impacts. In spite of these balancing out powers, Pluto's circle isn't actually steady. Mathematical recreations from the last part of the 1980s demonstrate the way that even little varieties in Pluto's situation or speed can prompt huge changes in its circle north of millennia. This turbulent conduct features the sensitive equilibrium in our planetary group, which can be upset under the right circumstances. The gravitational impact of the Goliath planets in the planetary group can't be misjudged. All of the planets, including Pluto, are strongly influenced by Jupiter because of its enormous mass. Despite its smaller size, Saturn also plays a significant role in shaping the orbits of nearby stars. Together, these monsters assist with balancing out Pluto's circle, guaranteeing it stays on a steady way for billions of years. However, Neptune and Pluto have a special relationship. Because of their 3:2 resonance, Pluto completes 2 orbits for every 3 revolutions that Neptune makes around the Sun. This reverberation keeps up with Pluto's circle and keeps it from colliding with Neptune. But what happens if this delicate equilibrium is upset? Could the effect of another article, like a passing space rock or comet, modify Pluto's circle and placed it on an impact course with Neptune? Astronomers continue to be intrigued and concerned about Pluto's orbit, despite the stability provided by their resonance. The idea of occasional mayhem, where little changes in the position or speed of a heavenly body lead to enormous changes in its circle over the long run, is particularly valid for Pluto. Indeed, even minor changes in Pluto's situation or speed can essentially affect its drawn-out direction. Programmatic experiences have given important knowledge into this turbulent nature by demonstrating the way that little changes can prompt boundlessly various outcomes. The astronomical community has been concerned about the possibility of Pluto and Neptune colliding. Michio Kaku and Neil deGrasse Tyson, 2 well-known astrophysicists, have voiced concerns regarding the potential outcomes. Tyson, who was instrumental in reclassifying Pluto as a dwarf planet, has expressed concern regarding the perils posed by the 3-body problem, pointing out that a collision could result in severe consequences. For Pluto, an impact could be disastrous. Because of its little size and frigid synthesis, Pluto would probably be annihilated by the effect, dissipating garbage all through the planetary group. The stability of the entire solar system could be disrupted by this debris, which could pose a threat to other planets and moons. Neptune, however bigger, could likewise encounter tremendous changes. The crash could modify Neptune's environment and have significant ramifications for the planet's elements, possibly upsetting the equilibrium of the planetary group. Leading theoretical physicist Michio Kaku provides a novel perspective on the potential collision. His work in string hypothesis and comprehension of heavenly mechanics give further experiences into the powers at play. Kaku sees the investigation of Pluto's circle as a window into what's to come. By understanding planetary collaborations and orbital elements, we can acquire important information to direct our investigation of the universe. We can use this information to plan missions to the farthest reaches of the solar system and to make disaster predictions. Kaku also emphasizes the connection between fundamental physics and celestial mechanics. The fundamental laws of the universe control the gravitational interactions between Pluto, Neptune, and other planets. These interactions are not random. Concentrating on these cooperations assists us with grasping the key powers that shape our universe. The Kuiper Belt, a region of the solar system beyond Neptune inhabited by numerous small icy bodies, is also related to Pluto's orbit. As one of the biggest individuals from the Kuiper Belt, Pluto's circle brings it profound into this district, where it interfaces with other Kuiper Belt objects. The energy of these articles, alongside the mass appropriation in the Kuiper Belt, makes unobtrusive aggravations in Pluto's circle. These aggravations can make the circle float and slant, adding intricacy to the elements of Pluto's circle around the Sun. Understanding these communications is critical for getting a total image of Pluto's orbital mechanics. As well as communicating with the Kuiper Belt, Pluto is affected by its bigger moon, Charon. Because neither Pluto nor Charon has a center of mass, the Pluto-Charon system is unique. Pluto's orbit and interactions with other planets are affected by this mutual orbit's magnetic interaction with Charon. Styx, Nix, Kerberos, and Hydra are the 5 small moons of Pluto, with a 5th moon recently discovered. Albeit these moons apply little impact on Pluto, their presence adds layers of intricacy to the elements the Pluto framework. We can learn more about how smaller bodies interact with larger ones by studying these moons. Astronomical observatories are one of the main tools for understanding Pluto's orbit.